So we're looking at two things. We're looking at dot plots and we're looking at box plots. Box plots are formally known as the box and whisker plots. Now, yesterday and the day before, we looked at taking populations, large groups, and then finding samples from that population. Once we have our samples, we can collect data from our samples and make inferences about our population. We can display that information in these two ways. The first one that I want to look at is dot plots. So we are curious, let's say backpacks. So we want to know how many kids are taking home books in our school. Yeah. So we want to know how many students, let's say in 7th grade, are taking home books each night. It'll be really, really difficult to ask every single 7th grader. So what we're going to do is we're going to make a sample that we can use to then make a prediction about our full population of all 7th graders. Let's say that we talk to 9 kids. We just randomly choose 9 students. And we look in their bags and they have 2. One has 6 books, one has 1 book. Somebody has 0 books. 4 books. 1 book. 4 books. 2 books. And 2 books. So the first thing that we're going to do anytime you have a data set is to organize it least to greatest. So I'm going to start with 0, so I'm going to put a 0 here. And then my next is 1. So 2 kids had 1 book. They had 2, they had 2, they had 2. So 3 students had 2 books. 2 students had 4 books. And then somebody had 6. So now our data is all organized least to greatest. Now to create the actual plot, we're going to make a number line that'll fit all of our data. So maybe start with 0, 1, 2, 3, 4, 5, 6. So we've got our number line. And then we put dots to represent each person. 1 person had 0, so we're going to put a dot at the 0. 2 people had 1 book, so with 1 here, we put 2 dots. Now it's important that our dots are all the same size and the same distance apart. If our dots were different sizes, it would be hard to compare the data. 3 people had 2 books, so we put 3 dots here. 2 people had 4 books. And 1 person had 6. So this is the sample that we collected from these 9 kids. we can make some inferences about our larger population from this sample. Based on this data, how many books do you think most seventh graders are taking home? Based on this, it looks like 2, somewhere between this range right here. It looks like this is kind of where most of those kids are taking home books. We could say that 2 looks like to be a pretty average number of books that people are taking home. That might be the most. Do you think that there's kids taking home 3 books?
Yeah.
7th graders, do you think there's some 7th graders taking home 3 books? Do you think there's more kids taking home 3 books or 5 books? 3, right? If I'm looking at this set of data right here, it looks like it's kind of peaking. So I bet we can make a reasonable estimation. We can make an inference based on this graph that there's probably kids taking home 3 books. The kids that we asked didn't have 3 books. But based on our graph, we can see that there's probably kids with 3. What about more than 6? What if we kept going out here and here? Would we have fewer students or more students? Fewer, right? If I started to ask more and more students, we're probably going to get less numbers out here and more numbers in this area right in here, which leads us to believe that most kids are kind of in this range right here. So maybe have less than 5 books in their backpacks. So we've looked at dot plots and how we can use dot plots to infer data about our population. Let's look at box plots. So we ask, we're going to ask 9 other 7th graders how many pets they have. Because our population, we want to know how many pets 7th graders have. It'd be really difficult to ask every single 7th grader. So we're just going to sample 9 kids. So we're going to sample them and say, one of them's got 9, 2, 0, 4, 6, 3, 3, 2, and 5. So we asked 9 kids, and this was what they came up with. First thing we do when we have a data set, put them in order, least to greatest. So start with my 0. There's no 1s, but there's 2 people who had 2 pets. Two people that had 3 pets. Somebody had 4 pets. 5 pets. 6 pets. And then 9. Might be like fish in a tank kind of situation. 9 pets seems like a lot. Now for box plots, we have to find some information before we can graph. We have to find our lowest value. Our lower quartile. Our median. Higher quartile, and our highest value. It sounds like we're going to be doing some really difficult math, but you're about to see here in a minute that it's really not that much. In fact, 3 of these you've been doing for a really long time. Our lowest value is 0. So I'm just going to put a 0 out here so we can keep track of that. Our highest value is 9. So we put a little 9 out here. Keep track of that. So far, so good. The next thing I'm going to find is the median. The median is the middle number. Cross off, cross off, cross off, cross off. So that 3 is our median. So keep track of that. Our lower quartile is the median of our lower numbers. Cross off, which we've got 2 and a 2. The number in between 2 and 2 is 2. So our lower quartile is 2. Our higher quartile is the median of our higher data. Cross off, cross off. The number between 5 and 6 is 5.5. We create a number line just like we did for a dot plot. Start with 0. We have to go all the way up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we just put dots at each of those spots. So I'll put a dot here at 0, a dot at 2, a dot at 3, 5.5, and 9. Then we create the box. The box is created by connecting those quartiles. And we connect our lower and our higher data to our box. You can see why it used to be called box and whisker plot. I think that this graph is the most underrated graph that we use. Half of the students are represented here. Half of the students are represented here. So when we look at our box and whisker, this is our median, this is our median. So half of the students have 3 to 0, and half the students have 3 to 9. What this tells us is that most of the students are in this range right here. Half of the data is kind of in between these 0, 1, 2, and 3 pets. This distance right here in between the quartiles is where a lot of our data is. Most of our data is in between 2 and 5.5 pets. So 2.5 to 5.5. Most of the middle part of our data is right in that range. You can see the median, the middle is a little bit closer to the bottom end. All of this data is being kind of put in this distance over here. fewer and fewer people as you move to the right. Less people have 9 than 5. More people are in this denser, more closely smashed together little area. Once we look at our dot plots and make inferences on our population on dot plots, making inferences about our population based on our box plots, the next thing we'll do is start comparing box plots and dot plots together. So I'm going to start with posing the question, and then I want you to graph both a dot plot and a box plot given this data set. So we asked 10 kids how many hours they spent playing video games on Monday and Tuesday, and this was the results. So we asked 10 seventh graders how many hours they spent playing games, and this is our sample. We want to know how many of all the seventh graders played, the number of hours that all seventh graders played, but this is the sample from that population.